Hi everyone, my name is Christian Mihailoff, and today I'm going to walk us through a price elasticity of demand model using a real world business scenario. My goal today is to show you step by step how to use elasticity to decide on the best pricing strategy or optimal pricing with a full algebra and labeled diagram with clear managerial takeaways and steps for the future. So jumping right into it, the price elasticity concept or model basically measures how sensitive customers are to changes in prices. So we can see here by using the formula of percent change of quantity over the percent change in price, we can decipher if the product is elastic or inelastic. So if we notice here that the price elasticity of demand is greater than one, then the demand is elastic and customers are going to respond strongly to price changes. And if it is less than one, then the demand will be inelastic, causing customers to barely respond to changes in prices. And if the price elasticity is equal to one, then the demand is unit elastic and it proportionately changes due to circumstances. Okay, now let's apply this to a managerial scenario. For example, Joe's Smoothie Bar. Suppose that we currently sell a smoothie at $10 and we typically sell 1,000 smoothies per month. Each smoothie costs us about $6 in ingredients, cups, and labor. And now, the big question for us as managers is should we raise the price to improve margins or lower the price to increase volume? If we get this wrong, we risk losing customers or leaving money on the table. This is where the elasticity of demand comes in. Let's assume, based on a quick market survey, that the elasticity of demand for our smoothies is about negative 1.5%. That means for every 1% increase in price, quantity demanded falls by 1.5%. Okay, so let's actually test out what happens if we raise our price by 10% from $10 to $11. So, using the elasticity of demand formula, we can notice that the change in the quantity demanded would be our original negative 1.5 times 10% of the 10% price change, and we would get negative 15, which means if we increase the price, then the quantity demanded will drop by 15%. So if we go back to the original 1,000 smoothies that we sold and multiply that by 1 minus negative 15, we get 850. So if we change the price to $11, we are now selling only 850 smoothies instead of 1,000. So before the price change, our revenue would have been $10,000, and after the price change, our revenue is now 9,350, meaning that we actually lose out on about $650. So even though each smoothie is bringing in an extra dollar, overall revenue actually falls because the demand is super elastic. So customers are too sensitive to this price increase, and the loss in sales actually outweighs the gain in price. Okay, so now that we've been able to test a price increase, let's test a price decrease and do the opposite. So cutting our price down by 10% from $10 to $9, we can put that into the formula and use our original elasticity of demand of negative 1.5 and multiply it by negative 10 to give us a positive increase of 15% quantity demanded. So therefore, if we put that into quantity demanded formula, we can multiply 1,000 by 1.15 and get a new quantity demanded of 1,150. Therefore, our revenue at $9 instead of $10 actually becomes 10,350, meaning that our revenue overall with a price decrease is going to increase. This is probably because our elasticity of demand is so high in this case scenario. So customers want to buy more smoothies at the lower price, and the business earns more revenue overall. Okay, so here's a diagram of the price elasticity of demand for the smoothie bar scenario. So we can see that our starting point at 10 and 1,000 quantity demanded. The purple box shows our revenue gained an amount for that specific starting point. And then if we move up to $11, the quantity falls to about 850, and the total revenue actually shrinks. The total area of the green box shrinks. And then if we move down to $9 and 1,150 quantity demanded, the total revenue expands to about just over the starting point. So the demand curve shows that the movement's pretty clearly that the size of the revenue box and the price times quantity grows when we lower the price in the elastic range that this smoothie bar scenario is in. Okay, so what does this mean from a managerial perspective? So at our starting point of $10, we were making $10,000 in revenue. When we tried raising the price to 11, the revenue dropped to 9,350. When we lowered it to $9, revenue increased to 10,350. The model told us this would happen because the demand is very elastic, meaning that customers are very sensitive to this price change. This shows that charging more per unit doesn't automatically mean earning more money overall. In fact, if your customers are elastic, and in this case they are, raising prices can backfire very badly. You'll end up with fewer customers, less sales volume, and even in this case, less revenue. So on the other hand, lowering the price can be a smart strategy in elastic markets. Sure, the profit margin on each smoothie goes down a bit and you're only earning $3 profit per drink instead of 4, but because so many customers are willing to buy more at this lower price, the overall revenue and profits still increase. For the smoothie bar manager, this means that the volume is more important than the margin per unit when demand is elastic. So you want to capture as many students as possible because each additional customer brings in more revenue that outweighs the smaller per drink margin. So I just wanted to note a big key takeaway from the price elasticity of demand model, and it's knowing whether or not your customers are elastic or inelastic can completely change your pricing playbook. Meaning that elastic demand, you're going to focus on competitive pricing and volume growth, and inelastic demand, you might focus on margin and capturing more profits per sale. So understanding where you are on that spectrum is definitely the difference between leaving money out on the table and maximizing your results and revenue. So now that we've looked at what happens when we increase and decrease price, let's look at what happens when the elasticity itself changes with 2 new cases. So let's look at case 1 here where it's during exam week and the inelastic demand might rise. So elasticity might drop to negative 0.5, raising our prices by 10%. So quantity only drops to 5% to 950. So if we put that in the revenue calculation, we notice that 11 times 950 is actually 10,450. So here, raising our price actually increases revenue. Let's look at another case during summer break where elasticity might be very high. So elasticity could rise to negative 3 and a 10% price cut, quantity rises by 30% to 1,300. So now if our price is at $9 and we multiply that by 1,300, it equals 11,700. So here lowering our prices actually massively increases revenue. One thing I want to note is that the model doesn't give one fixed answer, and it really depends on when and where you measure elasticity. Okay, so now you might be wondering, how can a manager actually measure elasticity in real life? It's not like customers walk in and tell you, hey, my elasticity is negative 1.5. You have to figure this out using data. One practical method is to run small pricing experiments. So for example, the smoothie bar could try and lower the price from $10 to $9 for 1 week and carefully track how many smoothies were sold. Then, using the midpoint formula as shown below, you can estimate elasticity. The formula avoids overestimating or underestimating by taking averages in the denominator, and it gives you a more reliable elasticity number. Another approach is to look back at historical sales data. So if you have records of how many smoothies were sold at different prices in the past, you can run a simple regression analysis, often a log-log regression, which gives you an elasticity estimate directly from the slope. It's also important to remember that elasticity is never fixed. It changes on the time of day, season, and the competitive environment. For example, like we did before with the cases, during exam week, students may be less price sensitive, so the demand is more inelastic. And during summer break, when there are more alternatives, demand might be very elastic. Even within a single day, demand could vary. Maybe mornings are more inelastic because students need caffeine, while afternoons are more elastic because they're choosing between multiple treats. For managers, this means elasticity should be treated like a moving target. The best strategy is to re-estimate it regularly and adjust when consumer prices, responsiveness changes. A smart business doesn't just set one price and forget it. They continually test, measure, and adapt. So in practice, price elasticity is more than just a formula, it's a decision, and it's a tool that connects customer behavior with pricing strategy. So to conclude, in our smoothie bar case, with an elasticity of -1.5, lowering price increased revenue while raising it decreased revenue. But in certain situations like exam week, higher prices make sense. And in high elastic times like summer break, lower prices make sense. The one big key takeaway here with the elasticity of demand model is that don't guess your prices. Measure your elasticity and let it guide your pricing decisions. Thank you all for watching.